Hello, my dear student. How are you? I hope all of you are well and doing good. So, let's start today's lecture. That is your lecture number 2. Okay, lecture number 2 of theory of metal cutting. I hope you understood the last lecture, right? I hope you people understood the last lecture. Yes. So, let me wait for other people. Let me wait for other people so that we can start our session. Jayesh, good evening, beta. Good evening. How are you? How are you feeling today? Jayesh, how are you feeling today? Yes, so let's wait for other. Then I'm going to start the session, right? Yes, so I hope my sound is clear now. I hope my sound is clear now. Yes or no? Let me know. Yes or no? My sound is clear? Yes? Okay. So, in today's lecture, we are going to cover, right, types of rake angle, types of machining, right, geometry of single point turning tool. It may be I'm going to start or not, okay, but this is the major topic which I'm going to cover, right? So let's start today's session, my dear. Let's start today's session. Here, see, types of rake angle. So you have seen the rake angle. You have seen the rake angle, right? Let me show you. You have seen the rake angle, and you have seen the rake angle like this, right? This is your tool, my dear, right? This is your tool. This is your tool, right? This is your tool. This is your workpiece, sorry. And this is the shear plane, and this is the, right, this is the shear plane, or this is the workpiece which you produce during machining. And here, this is what, this is the shear plane, right? And my dear, this is what, this is a reference line. Remember what I told you? This is a reference line. This is a reference line, right? Or normal line, or normal line. This is a reference line or normal line. Good evening to all. So let's come. So my dear, here the tool which is coming toward the workpiece to cut the, okay, to cut the workpiece, is moving toward the workpiece to cut the workpiece. This is what, this is tool, and which is moving toward the workpiece with a cutting velocity v, right? With a cutting velocity v. This is what, this is the cutting velocity. This is the cutting velocity, right? This is what? This is the cutting velocity. My dear, here you see the inclination of rake angle, the inclination of, sorry, the inclination of rake surface. This is what? This is rake surface. This is rake surface, right? Now, my dear, this is a reference line, and this reference line basically is what? This reference line is basically perpendicular to the horizontal surface, that is along the machine surface. That is along the machine surface. So my dear student, this is what? This is the machine surface, and if you draw the line along the machine surface, okay, and that line is perpendicular to the machine surface. Are you getting this thing? Now, my dear, please listen. This is a reference line. Now, from where the tool is coming? From this side, tool is coming. So, write down, this is the positive side and this is what? Negative side. From where the tool is coming? From where the tool is coming to the reference line, take that side. Sir, Hindi में भी होगा? Yes, it will be. बेटा हिंदी में भी होगा. It will be conducted in Hindi on our Hindi channel. This is an English channel, so that's why we are going to discuss in English, right? Vishal Bharadwaj. Okay, so the tool is moving toward the workpiece, and that side of the reference line is positive because cutting velocity lie here. So this is a positive and this is a negative. Now, my dear, see the inclination of the rake face. This is what? This is a rake face. See the inclination of the rake face from the reference line. From the reference line. Now, this is what? Rake angle. Rake angle lie in which side? Rake angle lie in which side? Yes, DPP or notes कहाँ मिलेंगे बेटा? DPP and notes are available in the PW app, right? DPP and notes are available in the PW app, right? So this is a alpha which lie in the positive side. So that's why this is what? This is a positive rake angle. This is positive rake angle. Am I clear? This is positive rake angle. Yes or no? Let me understand. Let me clear this concept. This is what? This is positive rake angle. Yes, is it clear? Yes, is it clear? Yes or no? Will DPP provide it? No. Right. So here you can see this is your workpiece, right? You have seen that. So what I'm going to do here, I'm going to do to make a finished surface, right? I'm going to draw a finished surface. This is what basically, my dear? This color represent what? A finished surface. This color represent what? Finished surface. So here, this is the finished surface. Now, you have seen the reference line. This is what? Reference line, right? This is what? Reference line. Let me take the copy of this reference line. This is what? The reference line. My dear, this is the reference line and this is the tool, right? This is the tool which is coming toward the workpiece. This is the tool, right? This is the tool, right? This is the tool. Now, okay, see here. See here. Now see, my dear, see, this is the tool. Now the tool is coming from this side with a cutting velocity of what? V. From the cutting velocity of what? V. Now this is a reference line. Now the inclination of the rake surface. Now this is a reference line or normal line. This is what? Normal line. Okay. This is what? Normal line. Now the cutting velocity will lie in this side of the normal line. So make it that side is what? Positive and that side is what? Negative. This is rake surface because chip will flow along that face during cutting. You have seen that chip will move along that face. Okay, so chip will move along that face, right? The chip will move along that face, my dear. The chip will move along that face. So the inclination of the rake surface from the reference line or normal line is known as what? A rake angle. This is what? This is the rake angle. So this is a positive rake angle. Yes or no? Yes or no? Yes or no? Here, this is what? This is the positive rake angle, right? This is what? Alpha. This is positive rake angle. Am I clear? Positive rake angle. Positive. Beta DPPs are available, right? Oh, sorry, notes are available. You don't have to pay for the notes, right? Notes are available for okay, free. Notes are totally free, and the notes are available on the PW app. And the notes are available on the PW app. Is that clear? Now, this is positive rake angle, my dear. Now, let me know. Is that point is clear? Now, my dear, let's say the tool rake surface. Okay, this is your tool again. This is your tool again, right? And tool is moving from this side, and tool is moving from this side with a cutting velocity v. With a cutting velocity v. Now, this is a reference line now. This is what? This is a reference line now. That side is what? Positive, because cutting velocity is coming from that side. So take that side is positive and that side is what? Negative, right? That side is what? Negative. My dear, here the inclination of rake surface, because the chip will flow along that face. The chip will flow along that face. Yes or no? My dear, this will be the rake surface. Here the inclination of the rake surface. Here the inclination of the rake surface from the reference lines is what? From the normal line is what? From the reference line is what? Are Baba, tell me. From the reference line is what? The inclination of the rake surface. The inclination from the rake surface, from the reference line, from the normal line is what? Tell me. The inclination is 0 now. The inclination, here the alpha, here the alpha, that is inclination is what? So this is 0 rake angle. This is what? 0 rake angle. 0 rake angle. Am I clear? Now, if this is the tool, let's say, if this is the tool, let's say, this is the tool, let's say. Now, if this is the tool, let's say, this is the tool, let's say, right? The tool is moving toward the workpiece as usual. The tool is moving toward the workpiece to cut the, okay, to cut the material. To cut the material with a cutting velocity of what? V. This is a reference line. So take that side is what? Positive. So take that side is what? Positive. And that side is what? Negative. My dear student, here the chip will flow. Here the chip will flow along that rake. Yes or no? The chip will flow along that face. So this face become rake face. This face become rake face. Now see the inclination of the rake face from the reference line. See the inclination of the rake face from the reference line. It is what? Negative. Because the inclination of the rake face from the reference line is what? Alpha, that is rake angle. It will lie in the negative side. So it will be what? Negative rake angle. So here, this is what? Negative rake angle, right? Negative rake angle. Yes or no? Tell me, this is what? Negative rake angle. This is what? Negative rake angle. Is that point is clear? Is that point is clear? Let me know. Is that point is clear? Is that positive rake angle, negative rake angle, the concept of positive rake angle? Good evening to all. The concept of positive rake angle, 0 rake angle, and negative rake angle is clear? Yes. The concept of positive rake angle and your negative rake angle is clear? Yes or no? Let me know. Yes. Yes, people, I want to know that you understood the concept of negative Positive or zero rectangle? Yes or no? Let me know. Yes, my dear people, let me know. Do you understand the concept of negative? Do you understand the concept of negative rectangle? Okay, positive rectangle and zero rectangle. My dear, here, this is the tool, right? This is the tool. Okay. This is the tool which I am drawing here separately, right? Which I am drawing here separately. See, this is the tool, right? This is the tool, right? My dear, in the yesterday class, I told you this point is represent as cutting edge. This point is represent as cutting edge. Yes or no? This point is represent as cutting edge. Yes or no? This is what? This is the cutting edge. This point is represent cutting edge. I told you in the last class. My dear, behind that cutting edge, please see. This is the material of the tool. This is what? This is the material of the tool, right? This is the material of the tool. Basically, this material will support the cutting edge. This material will support the cutting edge. That's why we call this is supporting material. This is supporting material. This is what? Supporting material. To whom? Supporting material to cutting edge. Because that material lie behind the cutting edge. Yes or no? Is that point is clear? 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 My dear, you can see this is the cutting edge, right? This is a blade, basically, simply. This is a blade. Behind this blade, there will be a material that is known as what? Supporting material that support the cutting edge. Supporting material that support the cutting edge. Now, let me give the answer. Please give, I'm going to ask one question. I'm going to ask one question and you have to give me the answer. What is the question? In which case supporting material is less? Let's say this case is what? Let's say this case is 1, this case is 2, and this case is 3. These are the 3 tools. Tool number 1, tool number 2, tool number 3. Yes. Now tell me in which case supporting material is less. Manish Kumar says, sir, in 1, supporting material is less. Yes, my dear. Here you can say this is the supporting material which is less. Now I'm going to ask, in which case supporting material is large? In which case supporting material is large? In which case supporting material is large? Tell me. In the third case, yes, my dear. In the third case, the supporting material is what? Large. My dear student, try to understand one concept. Basically, what is the function of supporting material? Okay, supporting material, please try to understand the function of supporting material. The function of supporting material. What is the function of supporting material? Basically, this supporting material will support the cutting edge. Support the cutting edge. The cutting edge. The cutting edge. This supporting material will support the cutting edge, right? This supporting material increase the strength of the tool. Increase the strength of the tool. The strength of the tool. Yes or no? Here you can see behind the cutting edge. Here you can see behind the cutting edge, the supporting material is less. So if the material is going to cut something else, it can easily bend. If the material is going to cut, okay, a workpiece which is stronger, it can easily bend, right? So if the supporting material behind the cutting edge is large, then strength of the workpiece increases, then the edge is not going to bend in easy manner. Yes or no? Tell me. Yes or no? Tell me. Yes or no, my dear student? Tell me, please. Yes or no? Tell me. Do you understand? Do you understand, people? Yes, my dear student. So here, supporting material increases the strength of the tool. So which tool is the strongest tool? My next question is, among the three tool, which tool is the strongest tool? Which tool is the strongest tool? Yes, give me the answer. Which tool is the strongest? Very good. So here, this is the strongest tool, my dear. This is what? This is the strongest. This is what? This is the strongest tool. My dear, which tool is the sharpest tool? Which tool is the sharpest tool among the three tools? Among the three, which tool can penetrate into the workpiece in a very easy? Yes, yes, yes. So this is what? This is the sharpest. This is what? This is sharpest tool. So it means here, this is the sharpest. So the required cutting force is less. So the required, let's say, here I'm going to write the required cutting force. The required cutting force is going to be represented by, let's say, what? FC. Let's say what? FC. Right. Let's say what? FC. Yes. Yes. Try to understand. This is a sharpest. So try to understand this is a sharp and this is not sharp. So here the required cutting force, let's say FC1. Here the required cutting force, FC, right 3. My dear, this is a sharpest, so the required cutting force is less. This is not sharpest tool, so required cutting force is high. So what is the conclusion? Conclusion is very simple. As the rake angle decreases, my dear student, as the rake angle increases, try to understand. Try to understand. As the rake angle decreases, as the rake angle going to decrease from positive to what? Negative. The cutting force increases. The cutting force increases. The cutting force increases. Right? Let's say the required cutting force in case 2 is FC2. So FC1 is the least, then FC2 is greater than FC1, and FC3 is greater than FC2. Yes or no? Yes. Do you understand this concept? Do you understand this concept? Do you understand this concept? Yes or no? Do you understand the concept? Yes, yes, yes. Right. So this is the sharpest and this is the strongest. Yes, this is the sharpest and this is the strongest. Right. The zero rake angle lie in between the positive and negative rake angle. So the property of the zero rake angle lie between positive and negative. The zero rake angle, my dear, try to understand. In the zero rake angle, the supporting material is greater than, supporting material is greater than positive rake angle, but in zero rake angle, supporting material is less than negative rake angle. So zero rake angle tool is more stronger than positive rake angle. Negative rake angle tool is more stronger than zero rake angle. positive rectangle. Here you can see the zero rectangle, the required cutting force, the required cutting force, the required cutting force in zero rectangle is more compared to what? Positive rectangle. The required cutting force in zero rectangle is less than what? Your negative rectangle. Yes, rectangle could be no idea. No, right? No, it not. Right? It not. Right? It not. If you're talking, okay. Yes. Okay. So I hope the concept is crystal clear to you people, right? Regarding the rake angle. Regarding the rake angle. With all due respect, only paid batches are showing, and in notes section only Gate to PDFs. There no Gate 2024. Dear, it will be. Please see properly. Deadpool. What is your name? Deadpool is a very interesting name. It will be uploaded soon, right? And I will inform to my backend team. They will upload it the notes. So at least be concentrate on in this session. You will get the notes very soon. I will update this information. I will update this information. Maybe you are not seeing the right section, Deadpool. Maybe you are not seeing the right section, right? That's why you are not getting the notes of the previous class, right? Your dear DPP is not available, right? So here the notes are available for you people, right? So I hope you understand the concept. Now, what is the types of machining, right? Now let's discuss the types of machining. Let's discuss the types of machining. Let's discuss the type of what? Type of machining. My dear, what is the meaning of type of machining, right? Actually, there are two type of machining. There are two types of machining. One is what? Your oblique cutting, and one is your orthogonal cutting, right? Your orthogonal cutting. One is what? Your oblique cutting, and one is what? Your orthogonal cutting. Let me write down here. The one cutting is known as here. Here, please see orthogonal cutting, right? Orthogonal cutting and oblique cutting. Oblique cutting, right? Oblique cutting. Try to understand. Here I'm drawing the tool. Please see. Here I'm drawing the tool. Yes. See. This is a tool, right? And this is the workpiece which I'm drawing here. This is the workpiece which I'm drawing here, right? This is the workpiece which I'm drawing here. Try to understand the concept. See, this is a workpiece, right? Are you getting the thing? See, this is your workpiece. Yes. Are you getting? Now the chip is flowing. Now the chip is flowing, right? When you are doing a cutting operation, it is obvious that is a cutting edge. That cutting edge basically, my dear, right? let me make the copy of this diagram. Let me make the copy of this diagram, right? And here I am to make the copy. And first of all, I am going to explain the orthogonal cutting first, right? Orthogonal cutting first. Try to understand this thing. Try to understand this thing, my dear. My dear, try to understand this thing. Here, this is the workpiece which I am going to cut, right? This is the workpiece which I am going to cut, right? This is the workpiece which I am going to cut, right? Now, here, this workpiece is going to cut. See, see properly. See, yes. Are you getting the thing? Now the chip is flowing. Now the chip is flowing, right? This and this. This is the chip. Yes, tell me. Do you understand the figure? This is the cutting edge, right? Here basically this cutting edge is little bit, right? Here this cutting edge is little bit basically, oh my, yes, see here. This is basically is what? Your cutting edge. Yes, this cutting edge is little bit, okay? Leave it here. Now see, are you getting this thing? My dear, here the cutting velocity by which the tool is coming out. This is what the cutting velocity. This is what the cutting velocity of the tool. Here the cutting velocity and this is what? This is the axis which is along the tool edge, and this is, let's say this is a y-axis, and this is what? Your z-axis. And let's say here this axis is known as what? This axis, this not this. This axis is known as what? This axis is x-axis. So my dear, this is x, this is y, this is z. My dear, in okay, let me take the copy of this figure. Okay, now please try to understand. My dear, when the cutting velocity is perpendicular, okay, try to understand this thing. When the cutting velocity is perpendicular to the cutting edge, when the cutting velocity is perpendicular to the cutting edge of the tool, and here cutting edge is lie along the y-axis, okay, so this is a condition of orthogonal cutting. This is a condition of orthogonal cutting, right? When the cutting velocity is perpendicular to the cutting edge of the tool, then this is a condition of orthogonal cutting. Also, the chip which is flowing. This is the chip, right? This is the chip which is flowing. This is the chip. Let's say this is VC, and that VC is nothing. It is equal to chip velocity. It is equal to chip velocity. Am I clear? Here, that chip velocity is also perpendicular to the cutting edge. Here, that chip velocity is also perpendicular to the cutting edge, which is lie along the y-axis. Tell me, do you understand the concept? Do you understand the concept? Yes or no? Let me know, my dear people. Do you understand that concept? Yes or no? My dear, here in a oblique cutting, right? In a oblique cutting, in a oblique cutting, right? In a oblique cutting, this is what basically, this is a z-axis. In a oblique cutting, what is going to be happen? Let me show you. Basically, this is a y-axis, right? This is a y-axis, right? You can see this is a y-axis, and This line is basically the cutting edge. Here you can see, if you are going to see the cutting edge, here cutting edge is going to incline. Here cutting edge is going to incline from the y axis, right? From the y axis. This is what? This is the y axis. And this is what? This is the inclination angle. Here I is what? I is inclination. Inclination angle. I is what? Inclination angle. So here there will be an inclination angle of cutting edge from the y-axis. So here this inclination angle is not 0, and here the inclination angle, here the inclination angle of the cutting edge, here the inclination angle of the cutting edge, okay, here the inclination angle of the cutting edge from the y-axis is what? Equal to 0. Yes or no? Yes or no? Do you understand this concept? Do you understand this concept? Yes or no? Let me know. How many are you getting this concept? In orthogonal cutting, inclination angle, that is what? Cutting edge. The inclination of the cutting edge from the y-axis is what? 0. In oblique cutting, the inclination angle, that is of from the that is the cutting edge inclination from the y-axis. There will be a inclination angle. Yes. Do you understand? Yes. Do you understand? Yes or no? Do you understand? Yes, 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 yes or no? Is it clear now? Yes, my dear. Is it clear now? Is it clear? Anybody has any doubt regarding this? Okay. So this is the thing, right? Now, now, please try to understand. Here, there will be a, right. Now I will show this figure again. For you people, I'm going to show this figure in a one plane. Try to understand. This is a very important. This is a very important, right? This is a very, very important thing. What I'm going to do here, I'm going to draw the figure. I'm going to draw the figure, right? See, see, this is a workpiece. This is a workpiece, right? And this is a workpiece. This time, please see. Shall I draw again? Okay, I will draw again. Please see. Please see. First of all, I'm going to draw the tool. This is a tool, my dear. This is a tool, right? See, this is a tool. This is a tool. Similarly, same to same figure I'm drawing here. Same to same figure I'm drawing here. See, see. So this is the tool, right? So this is the tool. See here. This is the tool. This is the tool, right? This is the tool, right? Here. Now, do you understand? I'm going to draw both figure on a same slide. See here. This is a workpiece. This is a workpiece, right? Let me draw the small workpiece. Let me draw the small workpiece. See, See here, idea. This is basically our tool, right? This is basically our tool, and this is the workpiece. Are you able to see? See here. See. See. Yes or no? Are you getting this thing? Are you getting this thing? Yes. Tell me. Now here, let me draw this figure. This is a very important thing. This is the cutting velocity. This is x direction. This is y direction. This is z direction. This is what? Sorry. This is your x direction, right? This is your y direction, and this is what? Let's say this is the z direction. Whatever you can take. So here you can say this is x, this is z, and this is what? Y. So here I'm drawing this figure again to you people. This is the cutting velocity. This is the cutting velocity. And here you can see cutting velocities along the x-axis, and cutting edge of the tool is lie along the y-axis. So the angle in between the cutting velocity and cutting edge is what? 90 degree, yes or no? Here again I'm drawing the same figure. Here again I'm going to draw the same figure, my dear. The same figure again I'm going to draw. Please try to understand this thing. Please try to understand this thing, right? Please try to understand this thing, right? Please try to. Within a, because why I'm drawing? I will take a ready-made figure. I will take a ready-made figure from the book, from the figure, but I want to draw in front of you so that you can understand the whole concept of this thing. Whole concept of this thing. Don't worry, I will not take not a last time. Don't worry, I'm not take last time. Within a small period of time, I'm going to make this figure. Don't worry. Here you can see, my dear. Here you can see this is basically the workpiece, right? This is your workpiece, right? Here you can see. Again, you say the same thing. The same thing. This is what? This is what? This is the x-axis. This is the x-axis. This is what? This is the z-axis. This is what? This is the y-axis. This is what? This is the y-axis. This is the x-axis. This is the z-axis. This is the y-axis. And here you can see the inclination of the cutting edge from the y-axis is what? I. Now the thing is crystal clear. Now the thing is crystal clear. Yes or no? Yes or no? I have removed the chip in both the case. I have removed the chip in both the case. So this is what, my dear, this is what? This is the orthogonal cutting. This is the orthogonal cutting. This is what? This is the orthogonal cutting, right? This is the orthogonal cutting, and this is what? This is your oblique cutting. Oblique cutting. This is what? This is your oblique cutting. So this is the figure which I have drawn in front of you. I haven't taken any ready-made figure, right? Because I want to draw this figure in front of you every time so that you can understand this the every step, okay, of this cutting. Is it clear? Is it clear, my dear student? Is it clear? Okay, okay, okay. My dear, one more assumption is that there will be an orthogonal plane. I will tell you. Okay, I will tell you. Basically, if you are going to talk about, if you are going to talk about the orthogonal cutting, if you are going to talk about the orthogonal cutting, orthogonal cutting, if you are going to talk about orthogonal cutting, please see this figure. Please see this figure, right? Please see this. Here you can see this is the figure, right? This is the figure, right? This is the machine surface, right? This is the machine surface, as you can see, and this is what? This is the shear plane. This is what? This is the shear plane, That is what A, B, right? And this is the tool, right? This is the tool, right? And this is the tool, right? And this is what the reference line. This is what the reference line, the normal line, the normal line, right? Try to understand this. My dear, in which direction? Let's say this is X direction. Let's say this is Z direction. This is X direction. This is Z direction. In which direction actual cutting force will act? In which direction actual cutting force, actual cutting force, in which direction actual cutting force will act? Yes. In which direction the actual cutting force will act, right? In which direction the actual cutting force will act? In Z direction. Okay. Okay. Here Shirish Ravi says in Z direction. Shirish, if I'm going to apply the force in Z direction, then how can this cutting will happen? Shirish, if you apply the force in this direction, basically your tool is moving. Try to understand, beta. Here your tool is moving with a cutting velocity. Here your tool is moving with a cutting velocity, right? With a cutting velocity of V. Here your tool is moving with a cutting velocity is V in X direction. My dears, my dear Sirish, if the tool is moving with a cutting velocity in X direction, then how come the actual cutting force will act in the downward direction? Then how come the actual cutting force will act in the downward direction? Yes or no? Now Himmat Singh say, sir, in X direction. Himmat Singh and Manish say, beta, if the actual force is acting in this direction, then in this direction the cutting will not happen. Have you ever have you ever done the carpentry shop? Have you ever done the carpentry shop? Have you ever done the carpentry shop? Yes or no? Tell me. Have you ever done the carpentry shop? Yes or no? Tell me. Yes, na. Suppose that this is a workpiece. This is a wooden workpiece, right? This is the wooden workpiece, and here I'm going to take, okay, the another. Let's say this is a cutting tool, my dear. Let's say this is what? This is a cutting tool, right? This is a cutting tool, my dear. Let's try to understand. See, you apply basically force in this way. Try to understand. This is X direction, right? This is X direction. This is Z direction. You basically apply the cutting force. Actually, look the direction of my hand. Your hand is going to apply the force in this way. Neither this direction is in X, neither this direction in Z, this direction in XZ plane. If you apply the force in X direction, then cutting will not happen. Then cutting will not happen. If you apply the force in the direction of Z, the cutting will not happen. Basically, you have to apply the cutting force in XZ direction in a plane. Yes or no? Are you getting this point? Yes or no? Tell me. Tell me. Yes or no? Your actual cutting force is not going to act in X, not going to act in Z. Your actual cutting force basically is going to represent by what? Is going to represent by R. That actual cutting force is going to act in what? In a plane. That is your R, my dear. If you take the component of R, if you take the component of R along the X direction, if you take the component of R along the X direction, then that force comes out to be, FC. If you take the, try to understand, if you take the component of R along the cutting velocity, if you take the component of R along the cutting velocity, then that component become cutting component. So FC is nothing, it is cutting component. It is what? Cutting component. It is nothing, it is what? Cutting component. Now, if you take the component of r normal to the velocity, then this component is basically a thrust component. So this is what ft, that is what thrust component. Thrust compo. Yes or no? Yes or no? Yes or no? Do you understand? Yes or no? Do you understand? Yes or no? Do you understand? Yes or no? Tell me, re yaar. Arey, tell me. Do you understand? When the component of actual cutting force, when the component of actual cutting force is normal to the cutting velocity, then it becomes thrust force. When the component of actual cutting force, when the component of actual cutting force will act in the direction of cutting velocity, then it becomes cutting component. So cutting is going to be done by FC. Because of FT, tools always remains in the contact with the workpiece. Right? Yes or no? Right? Yes or no? Do you understand? Yes, tell me no. Yes, tell me please. Do you understand this thing? Yes, do you understand this thing? Yes, do you understand this thing, my dear? Here again I am drawing the thing. This is the actual cutting force, and this is what, this is what the cutting component which is acting in the cutting velocity direction. This is thrust component, right? This is the FC which is acting in the direction of cutting velocity. This is FT, that is the thrust component. My dear, here you can see that this is the actual component. Here you can see that the angle between the component will always be a 90 degree. So this is a plane. So this is a plane. My dear, this plane is known as what? Orthogonal plane. Orthogonal plane. This plane will be orthogonal plane, my dear. This plane will be orthogonal plane. Right. So this plane, orthogonal plane is what? Orthogonal plane is a plane. Try to understand. Orthogonal plane is a plane in which the component of actual cutting force, that is FC and FT, will lie. That plane is known as orthogonal plane. What is orthogonal plane? Orthogonal plane is a plane where the actual cutting force has two component. Actual cutting force has two component, FC and FT, and both are what? Perpendicular to each other. That plane is known as what? That plane is known as what? Orthogonal plane. Do you understand this thing? Yes or no? Do you understand this thing? Yes or no? Tell me. Do you understand this thing? Yes or no? Do you understand this thing? Yes or no? Hello, everybody. Do you understand this thing? Yes or no? Let me know. Yes. Yes. Do you understand? Do you understand? Do you understand? Yes or no? Orthogonal plane, do you understand? Orthogonal plane is a plane where FC and FT will lie, okay, which are perpendicular to each other. That plane is known as what? Orthogonal plane. Yes. Here, the condition of orthogonal cutting is that whatever chip is going to produce, that chip is going to, that chip, whatever chip is going to be produced, that chip will flow in orthogonal plane. One more important condition is that chip flows, chip flows in orthogonal plane. Orthogonal. These are some important assumptions. There are various assumptions. These are the important assumptions which are not able to understand in a easy manner. There are one more assumption which is not very important. You can read your books, but this is an important assumption which I explain here. So chip always flow in orthogonal plane, my dear. So this board plane is a orthogonal plane basically. This board plane is what? Orthogonal plane. This is an orthogonal plane. This is an orthogonal plane. So the chip flow in orthogonal plane. Is that clear? In oblique, chip will not flow in orthogonal plane. In oblique, basically it is simple that in oblique cutting, chip will not flow in an orthogonal plane. In oblique, chip will not flow in an orthogonal plane. In oblique, chip will not flow in an orthogonal plane. Yes, is that clear? Is that clear? Tell me. Tell me, is that clear? Is that clear, my dear student? Yes. Let me know. Is it clear to everybody? Is it clear to everybody? Yes. Hello, my dear student. Is it clear? So, in orthogonal cutting, this is the important condition for orthogonal machining. Chip flow in orthogonal plane. Yes. So this is a very important. Okay, these are the very important discussion which we have discussed today. So here I'm going to stop this session here. Right here I'm going to stop this session here. So please revise this concept. Okay, when you are going to come in the next class, right? Because this is a very important condition which you understood, which you have to understand, right? So my dear, here I'm going to wind up this lecture. Here I'm going to wind up this lecture, and we are going to meet on Monday. I mean, on the next class. In the next class, as you know, this class is from Monday to Friday, right? Monday to Friday, right? So we are going to meet, okay, in upcoming Monday. Here I'm going to stop this session because these concepts are very important. Okay, these concepts are very important. This concept are very important, which I am going to repeat it again, which I am going to repeat again, which I am going to repeat again. In orthogonal machining, the cutting edge. In orthogonal machining, the cutting edge, okay. In orthogonal machining, the cutting velocity and cutting edge, the angle between the cutting velocity and cutting edge is what? 90 degree. In oblique cutting, the angle between the cutting velocity, the angle between the cutting velocity and the cutting edge is what? Not 90 degree. Not 90 degree. Not 90 degree. One of my students is asking, sir, how a chip is going to flow in an orthogonal plane? It's very simple. It's very simple, Hemant Singh. Look, very simple, beta. Look here. Like this. Basically, this is a two-dimensional figure, na? You are seeing this way. Look, Hemant. Basically, chip will be in the coil. The chip is flowing. What? See. This is a chip. Are you able to see this chip? Hemant, are you able to see this chip? No, beta. Because today we have discussed very important concept now. So that's why here I'm going to stop. Daily your class will be 1 hour 30 minutes. Okay, Manish? Daily your class will be 1 hour 30 minutes. But today I have discussed a very important concept, that is your orthogonal cutting, right? So you have to revise it and come in the next class. Then tomorrow onwards your class will be 1 hour 30 minutes, right? See, Hemant, you able to see? This is the chip. Now if you see the chip, this is the coil. Hemant, this chip is flowing only this plane, na my dear. This chip is flowing in this plane, na my dear. Hemant, this chip is flowing in this plane, na my dear. This is the actual cutting force, Hemant. The actual cutting force. This is the cutting component. This is a thrust component. So the coil is forming in which plane? Tell me, Hemant. The coil is flowing in which plane? Tell me, Hemant. Hemant, tell me. The coil is forming in which plane? This is the actual cutting force. This is the actual cutting force. This is the cutting component. This is the thrust component. So this is a plane now. This is a plane now. In this plane, the chip is what? Bending. The chip is not coming out like this. The chip is not coming out like this. The chip is flowing in which plane? The orthogonal plane. The chip is flowing in which plane? The orthogonal plane. Yes or no? Okay. So that is the meaning, that the chip is flowing in orthogonal plane. That's why today I'm going to take only 1 hour class, because as you people know, this concept is very important. So always remember that concept, my dear. Always remember that concept. Gate asked so many questions on this concept. That before completing production, should we study any material science basics from crash course? Yes, you are going to study before completing the production. Before completing the production, you are going to see the material science. Don't worry. And whatever the material science is required for you, I will provide during the lecture. Otherwise, in the crash course, you will get the full lecture of material science. Okay. Okay, Shirish Ravi, you are going to see a full lecture of material science in this crash course. And whatever concept is required of material science, I will provide. Right? I will provide. Right? Okay. You don't worry, your material science is not going to affect today's or upcoming lecture. Whatever concept is required, I will provide during my lecture. Yes, this is the kind, okay, one short series or detailed lecture series. Yes, are you getting this thing? Is it clear now? Is it clear now? Oh, mastermind, you are thinking like mastermind. It is better, mastermind, put or focus your mind to the goal. Put and focus your mind to the goal, to the concept, to the lecture. Don't deviate your mind. Don't differentiate the thing. The only thing is that whether the lecture is giving in one shot, whether the lecture will be given in in YouTube series, you are getting what? You are getting the concept. So my dear, be focused on the concept. It doesn't matter in which way you are getting. It doesn't matter in which way you are getting. Is this lecture enough for ESC? Hemant, in ESC, we required a detailed analysis. In ESC, we require a concept, we require a depth concept. And as you know, these concept, okay, as you know, this lecture is totally dedicated to gate. Yes, although it doesn't mean that this lecture is not going to be help in ESC. Yes, this lecture is also going to help to for ESC exam, but not okay, but not enough. I mean, here I have to add some more extra concept. I mean, 90%, 80 to 90%. Basically, what is the difference in between gate, my dear? Hemant Singh, what is the difference in between gate and ESC course? There is 10 to 15% difference in between gate and ESC, right? There is 10 to 15% difference in between gate and ESC course. So if you are going to cover gate, you are already going to cover 85% to 85 to 90% what course. So don't worry, right? For ESC, it required more, I mean 15 to 10 to 15% extra, right? Yes. Anybody has any doubt? Anybody has any doubt? Anybody has any doubt? Mastermind, as you know, in YouTube, we have a limited time. So we don't have such enough, time duration to give the detailed analysis. We have some limitation regarding bandwidth, right? Regarding slots. So we have enough time in the paid batch. So in the paid batch, we give the detailed thing, whether you are dealing GATE or ESC. Yes, mastermind. So please keep your mind active in the right direction. Is it possible to prepare for GATE while doing job? Yes, yes. It is possible, dear. It is possible. It is possible. If you are doing job, you will get a full Sunday, you will get a Saturday, right? So if you don't have a time in weekdays, if you don't have a time in weekdays, then dedicate your time in the weekend slot, right? If you have a little bit time in weekdays also, then you can prepare your subject in weekdays. Otherwise, slowly you can prepare your subject in weekdays. Otherwise, you can utilize your weekend, my dear. You can utilize your weekend. Okay, mastermind, you can utilize your weekend, right? So the only thing is that you have to be consistent. You have to be consistent. If you are consistent in your life, believe me, if you are consistent in your life, nobody is going to stop. Nobody is going to stop. The only thing is that you have to be consistent in your course, whether you are doing a crash course, whether you are doing any detailed course of the GATE. Okay, your consistency, your dedication is required in any competition, right? Anybody has any doubt, any extra doubt? Anybody has any extra doubt, you can ask. You can ask if anybody has any extra doubt. Yes, look, I have extra slide. I have the extra slide, like geometry of single point cutting tool. This is a turning tool. I have the content to deliver you. But what I'm thinking, but what I'm thinking that, what I'm thinking that you should revise the concept of orthogonal cutting and oblique cutting, right? Because it's a very important concept. I have my slides. I can teach you the next topic, but I don't want to force your mind. First of all, digest the concept which I have delivered today, right? Which I have delivered today. Then come in the next class. In the next class, we will accelerate our speed. My dear, when you are riding your bike or car, will you accelerate fully? Hemant Singh, Manish Singh, Hemant and Manish, will you accelerate your bike fully initially? No, na, no, na, no, na, no, no. You slowly accelerate your bike or your car so that it will get a pickup. Right, right. Yeah, there is a difference in between paid and crash course, my dear. In crash course, you will get a crisp thing. You will get a crisp thing in a small time. In because in the YouTube session we have a limited time. We have a limited time to discuss the thing. But in a paid class, we have enough time to discuss each and every, even your doubt, every single point we can discuss in the paid class along with your daily doubts. Yeah, you can ask your daily doubts in every slide. In every slide you can ask you can ask every doubt, okay, in at any time you can ask your doubt, okay. And in paid class we have a large bandwidth. In paid class we have a large bandwidth, right? We have enough time so we can discuss the thing in detail, right? Okay, yes or no? I hope the thing is clear. So tomorrow, I mean in the next class, I'm going to discuss geometry of single point cutting tool. It is again very important. It is again very important. And two important thing I'm not going to discuss. Slowly I'm going to accelerate your car or your bike, accelerate your mind, accelerate your mastermind. If I give full acceleration on first day, if I give full acceleration in the initial phase, then what happened? Tell me what happened, Hemant? What happened if you give full acceleration at the initial? What happened? Either your car or your bike will hit somewhere else. It will control, it will lose its control, it will lose its control. So I don't want you to lose your control. I want to grip, I want you to grip, I want you to grip, okay. I want your grip on the upcoming concept. Am I clear to everyone? Am I clear to everyone? Right? Yeah. Okay, so my dear, here I'm going to stop the thing. So please revise the thing. Please revise the thing in the upcoming class. So we are going to discuss the thing in detail, right? And from the upcoming class, okay, we are going to discuss the thing in detail. Don't worry. Okay, thank you very much. Good night.